Hello, sixth graders. I'm just hanging out here in my classroom, and it's a little chilly in this building, so I decided that maybe I would make myself some hot chocolate. Are you a little bit jealous? I love hot chocolate. I'm gonna got a nice cup of hot water here, and my spoon's a little bit cold right now because it's been sitting in my room, but hopefully that won't cool off my hot chocolate too much. I like to have a lot of chocolate in my hot chocolate, so I'm going to put 2 big scoops in here and maybe just a little bit more. Okay, mix that up a bit. Very chocolatey. Lick the spoon. Ooh, that spoon is hot. Why did my spoon get hot when it was just cold a little bit ago? Very strange. Well, let's do a couple experiments to see if we can figure out why my cold spoon from my cold classroom got hot in my hot chocolate. We're going to use what we have learned about how molecules move in hot things and in cold things to try to figure out that question. All right, so one definition. Heat. We all know what heat is, right? We can heat things up. We feel heat in the summertime. We feel cold in the wintertime. Well, heat is just energy. Heat is energy. So something that is hot has more energy than something that is cold. Okay? Seems pretty reasonable. Hot things have more energy than cold things. Well, then how did my hot chocolate make my cold spoon hot? That is what we're going to be studying. That's called conduction. Conduction is where an object or a liquid or a substance can transfer its energy, its heat energy, over to something that's cold and make that cold object warmer, right? So we are going to do a little demonstration here. Today I'm going to be using digital thermometers. All right, they're just a little bit more accurate and they're a little bit easier for you to see on these videos. So I'm going to turn that on, and I've got metal washers here in my hand, and I have them tied together with just a pipe cleaner. I'm going to take the temperature of these metal washers. Okay, so I'm putting them through the loop. I'm going to see what the temperature of these metal washers is. And the temperature is still going up. Okay, it has stabilized at 73.8. Okay, so at room temperature, which I guess maybe it's not so cold in my classroom, is it? Maybe I'm just cold. All right, so the washers, before we do this experiment, are 73.8 degrees. 73.8 degrees Fahrenheit. Okay, we are going to see how that temperature changes when we put those washers into some hot water. So I am going to try not to burn myself. That's what I'm always doing. I'm always trying not to burn myself. It doesn't always work. I've got some hot water here. I'm going to put it into an insulated cup, a styrofoam cup. It's a good insulator. We'll talk about what insulation is in future lessons. I'm going to take the temperature of this water just to see how hot it is. Okay. Got my thermometer in this hot water, and oh boy, is it ever hot. The water I have in this cup is coming in at, still going up, 169.2 degrees Fahrenheit. 169.2 degrees Fahrenheit. All right, so now what's going to happen when I put these room temperature washers into the cup? What do you think is going to happen? This hot water has a lot of energy, right? Lots and lots of energy. What is going to happen when I put these cold washers into this cup? What's going to happen to the temperature of these? And what's going to happen to the temperature of the water, do you think? Okay, so I'm going to stick these in here. Doesn't take very long in that hot water. Okay, I'll let them sit there just for a little bit. And if we really think about it, we know that this water has a lot of energy. And right now it's transferring some of that energy by something called conduction to the metal washers. And they're going to heat those up, right? At first we had washers that were 73.8 degrees. We've put them into really hot water, right? So we should expect this temperature of the washer to go up. Okay, well, let's take the temperature of those washers. Take them out of the water here. Put them onto the table. And not really an easy way to do this. Ooh, they are hot. Decreasing a little bit from the hot water. And the temperature of these washers now is 161.1. 161.1. So quite a big jump, right? 161.1 degrees Fahrenheit. Those washers really warmed up. What happened to the temperature of the water, do you think? Let's find out. Temperature of the water. It was at 169.2. And now it is at 166.3 degrees Fahrenheit. Okay, so a couple things happened here. We started out with some really hot water. We had room temperature washers. We put these washers into the hot water and they heated up very quickly. Why did the water decrease in temperature? It's in an insulated cup, so it isn't because it was sitting out. It wasn't sitting out long enough for it to have decreased that much. The reason being is conduction. It gave up some of its energy to these washers. Okay, some of these washers were cold or room temperature. They were put into the hot water and the energy was transferred from that water to the washers, increasing the temperature of the washers and decreasing the temperature of the water through something that we call conduction. Okay, it's transferring energy through contact. That water came into contact and it transferred its energy. We're going to try this in a different way. We're going to try hot washers in room temperature water and just see how that works. Okay, so I'm going to put these aside and get a little cloth to wipe up my mess. And now I have room temperature water. I'm going to put that into a cup. Don't have to worry about burning myself this time. Put room temperature water in here. And we'll take an initial temperature of that to see what the room temperature water measures at. And then I've got some metal washers that are in a pot of water right here. I've got them on, they're heating up in this really hot water right here. So we're going to put those hot washers into room temperature water and see what happens. All right, so Our room temperature water is not registering. I'm going to use a different thermometer because this one I think has a low battery. Okay, our room temperature water is 71 point, oh, still going down. 71.1. 71.1 degrees Fahrenheit. Now we're going to take the temperature of those hot washers. Now here's where I have to really worry about burning myself. These are really, really toasty. I'll lean this down a little bit so you can see. You can see the steaminess of it. All right, so if I put, ooh, hot, 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 hot. I'm just going to lay them right on top of the probe there and see what happens. Temperature is climbing. Temperature is climbing fast. It is at 108, 111, 114, 116. And we are going to be putting these into this room temperature water. So it's 118.2. 118.2 degrees. Okay. 118.2. All right. We're going to put those hot water or those hot washers into room temperature water and see what happens. I'm going to put the thermometer right into the water so we can see the change. Okay, so our water was at 71.1 degrees. It is already at 85.8. Wow. Okay, 85.9 degrees is how warm this water got. What did I say? 85.9 Fahrenheit. And now we're going to take the temperature of the washers to see what happened to that temperature. Okay. They even feel pretty cool right now. And the temperature of the washers is, they were 118.2. And after putting them into the room temperature water, they are now 72 degrees even. 72 degrees even. Okay, so looking at this, we can say that there was a lot of energy in this water, in this really hot water. And I think I might have been using a thermometer that was a little bit off because that seems kind of high, but we still get the picture here. So hot water, room temperature washers, and the temperature of the water went way down and the temperature of the washers went way up. Okay, opposite happened, hot washers and room temperature water. Our water started out at 71 degrees. Our washers were a steamy 118 degrees. And when we put them in the same container, the water came down considerably and the washers, or the water went up considerably and the washers went down considerably. And what's happening there, we're not adding anything to it. They have the same amount of energy. The same amount of energy is that we started with when these two things were separate. There's an amount of energy that this has. There's an amount of energy that this has. When we add them together, energy is not created or destroyed. We're not adding any more energy into it. We are just transferring the amount of energy between two objects. And that's what conduction is. I'm going to show you a little animation to kind of explain it in terms that we have been discussing. Okay, so I'm going to change this back to putting me in the corner here. And we have a heated spoon. Let's go back to the topic of hot chocolate because I'm getting a little bit thirsty and I know that my hot chocolate is losing energy, right? It's losing its heat energy to the surrounding air. It's giving it away to the surrounding air. Yeah, I can tell that it's not quite as hot right now. So if we zoom in to the spoon, okay, so you can see that the spoon molecules are vibrating, and when they come into contact with something hotter, these hot molecules are slowing down a little bit, and these cooler molecules are speeding up again, or up a little bit. And that'll continue until we reach a balance in temperature, right? Eventually, that hot spoon that's sitting in my hot chocolate and the hot chocolate itself will reach a common temperature, right? And until it's while it's uneven, the hotter object will always be giving energy to the cooler object. All right? Let's look at the opposite. Now we have a cold spoon. Okay, we're putting a cold spoon into in contact with really cold molecules. Okay, so we've got, they are actually speeding up these molecules right here, and these ones are slowing down. Okay, so it's creating a balance right here. Right? We have a heated spoon. It's going to be heating up. It's pretty cool to begin with. It's coming into contact with something hot. That hot something, soup in this case, is speeding them up. And then the opposite is true when we've got a hot spoon coming into contact with something cooler. That cooler thing is going to, this hot spoon is giving its energy to these molecules, speeding them up and slowing these molecules down. All right? With this concept, I would like for you to walk yourself through the little lab that goes with this concept that you'll find posted on Google Classroom. It's a little bit of a different format. We've been doing a Google Doc that goes with the labs, and now it's a Google form. I think that might be a little easier as far as you being able to edit and enter in your answers, okay? So what you're gonna find with our labs is that there's a little bit of reading there, but there's also a lot of video animations showing you things just like this and talking about the concept of conduction today. All right, so work your way through that and we will talk about it again tomorrow. Have a great day.